Okay, I did all these notes last night, and YouTube is still not posting them. So I'm going to try to do this again in smaller files and see if that will work. For those of you that don't know, I had surgery, and I'm out all week. So you'll be getting notes this week via YouTube. Today's notes are about the 12 basic functions. Okay, in each of these, I'm not going to read this to you. You can read the objective. But in each of these, we're going to go through and talk about what is the domain, the range, the roots, the y-intercept, increasing, decreasing behavior. That's where we're talking about slope. Symmetry, is it even or odd? Boundedness, we'll explain that a little bit more, but is it bounded above or below? The examples will make sense. Local extreme, that's where we're talking about a max or a min. Write that down. Horizontal asymptotes, vertical asymptotes, in behavior, and continuity. Big list. Okay, I'm going to try to do 2 of these and see if the video will post. The first 2 that are up are the identity function. You started the identity function in Algebra 1. It is just the line y equals x. And we're going to start each one of these with, is there anybody that can't be in the domain of this problem? Well, we can sub everybody into the identity. So the domain is negative infinity to infinity. The range, there's not anybody excluded, is also negative infinity to infinity. We can look at the graph, the roots, if you want to write next to that, the roots, that's a 0, that's an x-intercept, is x equals 0. And the y-intercept is the point 0, 0. Increasing intervals, remember we're talking about slope. Where is this thing increasing? Well, it's increasing everywhere. Negative infinity. Sorry, this area is not as nice as Notability. And decreasing, none. There's no relative max or min, so none. It would help if I put the E on that. It's a continuous function. I can draw it without picking up my pencil. It's an odd function. If I sub a negative x in, I get the exact opposite of what I started from. It is bounded above, it's not bounded above or bounded below. And then we need to talk about the end behavior. To do that, I'm going to talk about that in pieces here. And I'm going to color code because I did this last night and this is the first one I'm going to have to do it over. This is the left side. This is going down. Okay? When we describe it, we'll talk about it. It's down, or we might say it falls left. Now, the important part that I've got to get into this is the limit. And because I'm having to do this in YouTube, I'm not going to have enough room to do both. So I'm going to answer everything about the red one, and then I'm going to do the other side. So we would say the limit as x approaches negative infinity. That is all part of the name, and you have to have this in every question that we go through. The limit as x approaches negative infinity of, we have to tell it what function we're talking about. In all of our notes today, we've labeled them all f of x. And this is going down and away, so it is going to negative infinity. If you need to pause for a minute and get that written down, do so, because I'm going to have to erase the red to do the other side. Okay, purple. I'm going to talk about this side, purple. The end behavior on the purple side is it's going up, or we might say it rises right. There's a reason I'm writing all these words down. In limits, we would say that the limit as x approaches infinity, because we're going the positive direction now, of our function name, f of x, is going positive 2, so it's also going to infinity. Okay, next we have the squaring function, which is not what you called it all the way through Algebra 2, but you know this one. This is the parabola. It's a quadratic. You already know lots of things about it, so let's just fill in what we know. We know that the domain, I can sub anybody into this, so the domain is negative infinity to infinity. The range, though, if I look at the graph, this graph doesn't go below 0, so the range is 0 to infinity, and it does include 0. The root, is x equals 0. The y-intercept is 0, 0. We'll get to some functions in a few minutes where some of these answers will change, I promise. It's increasing from 0 to infinity. It is decreasing from negative infinity to 0. It does have an absolute min. I'm going to abbreviate. An absolute min at 0, 0. It is continuous. I could draw it without picking my pencil up. It is an even function. If I put negative x in, I get exactly what I started with. It is not bounded above, but it is bounded below looking at the y-axis. Sorry, I should say looking at the x-axis. It doesn't go below the x-axis. Now, again, I'm trying to fit all this limit stuff in here. So I'm going to color code again. So the orange side, I'm talking about it for a minute. What direction is it going? It's going up. Or we might say it rises left. All right, here's my big limit thing. The limit as x approaches negative infinity of f of x. Look back and see that's exactly what I wrote on the last one. The limit as x approaches negative infinity of f of x. But now this answer is going to change. This one, the first problem, the identity function went down, and this one's going up. So it's not going to negative infinity. It's going to positive infinity. Again, pause it if you need to, because I'm going to erase all the orange. So I can do another color. Doceri is not as nice as Notability and doesn't give me as much flexibility when I'm trying to write. So the end behavior, this side in green, is also going up, or we might say it rises right. And our big limit name, the limit as x approaches infinity of f of x. By the way, I'm going to be real picky about us getting all of that into the name. That's going to be on every question. But where does this one go? It goes up to a positive value, so it goes to infinity.